I am going to give you just a smidge of background before we start it. So you've all at least heard of the theory, the Big Bang Theory, right?
Yeah.
How long ago was that? Because that was the origin of everything, right? The origin of the universe. How long ago? 4.6 billion years is something, but is it the origin of the universe or is that the origin of Earth?
30 years, can I guess? Like 14 billion years ago?
Between 13 and 14 billion years ago, now, part of the problem with the Big Bang Theory, and the reason that I can't go too deep with you guys on it in here, is because a lot of our evidence for it is not biological. In fact, none of our evidence for it is biological. Why?
No one's
It's not really something that can be like tested that well.
We have a really hard time testing it. And biology is a specific study of living things. There wasn't anything living at that point. There weren't organisms on Earth as we recognize them. So biologically, we can't really provide evidence for it. So instead, our friends in physics give us evidence.
If there were no animals during the Big Bang Theory, what made animals form?
That's this whole chapter. So 14 billion years ago, scientists proposed that what happened was there was a super dense mass. And that super dense mass exploded. And it sent matter hurtling out into space. Hence, the Big Bang, right? An explosion. And like I said, it's a lot of physics that they give us evidence for this thing. And you know that Mr. Broussard was here and he talked to you guys about some of that evidence, right? He mentioned it. He talked about the physics and the equations and some of our constants and how if our constants were different, there's no way that life would have happened. There's no way the explosion would have happened in the way it happened. And physics, like in terms of laws of physics, he's absolutely correct. From what we know, this is the best running theory we currently have. And the one thing that people do ask, and he briefly mentioned it, I think. Well, okay. I think he briefly mentioned it because when he said it to you guys, I was like, oh, yes, and I attached it to previous knowledge that resided somewhere else in my brain. You might have heard it and not made the same connections, so I'll see if you remember it or not. He had suggested that there is evidence that the universe is expanding because of the colors of light that we see from stars far away. There is this thing that we call a redshift or blue shift. And you guys understand this with sound. You've understood this concept with sound since you were very little. So I'm going to have you think of an ambulance. You're able to distinguish if an ambulance with its sirens on is moving away from you or towards you. You can tell when you hear the sound. And no one had to teach you that, right? If no one explained it to you, you understood as a child. What is it about the sound that you know it's moving towards you?
It gets louder.
Is it necessarily louder, or does something happen to the way the sound sounds?
It sounds more like high pitch.
Pitch is precisely it. The pitch changes. And as it's moving away from you, what happens? Towards you is a higher pitch, away from you is a lower pitch, and holding still is somewhere in between the two. comes to rest, and it's still making the siren sound, it's a pitch in between the high and the low. How does sound get from the origin of sound to your ear? Waves. And if waves are moving towards you, they compress and they squish, right? They would shrink. And if waves, the source of the sound, is moving away from you, then the sound waves would get stretched out. Now this is where you have to think of like all those peaks and troughs. Did your grade school teachers do peaks and troughs with waves with you? So we're looking at something so here's a peak, here's a trough, and if you move it away from you, the peaks and troughs are going to get lower because the wave gets stretched, right? They're not as high. The amplitude is not as great. If it moves towards you, the peaks and troughs get taller, amplitude increases. So you guys probably call that the Doppler effect. If you were taught that effect in grade school of sound, it's the Doppler effect, right?
So basically just like a slinky only.
Mm-hmm. So there's the Doppler effect, like we said, it kind of like, you're like, yeah, okay, I've heard it before. Something I'm familiar with. When you start driving, you're going to rely on your understanding of the Doppler effect to predict in which direction emergency vehicles are coming from. The same thing happens with light. Light gets to your eye in waves. If the source of light is stationary, the light appears one color. If the source of light, so essentially white, if the source of light is moving away from you, it gets stretched out. If the source of light gets closer to you, it's moving towards you, it's going to squish. Now, the size of light waves, the amplitude, that matters. The length of the wave. So the length from here, a wavelength of light. Does that make a difference in the kind of light you see? Some of you are saying yes. Some of you are looking at me like, never really considered it before. If things appear red, then they're getting stretched out, then they're moving away from us. Why would they move away from us? Because at one point they were sent moving in that direction and no force has stopped it.
I'm confused. What do you mean if you see that?
So you know that when we use a telescope, what we're actually looking at is the light being reflected back to us, or being sent to us from distant things. That light appears white if it's not moving. If you look at it and it appears red rather than white, it's moving away from you. If it appeared blue, it's moving towards you. If it appeared blue, that would mean that the universe is collapsing back in on itself. Things are moving towards everything else.
I don't understand.
Typically, that sounds like it might be, bad. When things move back in towards themselves, there's a high probability of things running into each other. The idea of everything being hurtled out means things are moving away and we're getting a little more space. That's okay.
Wait, do you think it will like eventually hit something and come back in on itself?
I have no way of predicting that. By the laws of physics we currently know, and everything that governs the current known universe, it is improbable.
Improbable, but not impossible.
I say not impossible because I just don't know. I'm sure there's a physicist who knows. I'm sure Mr. Broussard would know. Metaphysicists, what are you going to do? So, makes sense? That's our evidence. Like, that's for biology's purpose, that's our biggest piece of evidence.
So is like the solid Earth getting bigger or the gases around it?
We, in, like, our,
Little bubble?
yeah, essentially like our galaxy, right? With the planets, we've all reached a fixed orbit. It's all of like the gases, essentially, all the space in between, if that makes sense.
I thought like some of the planets were going a little bit out of orbit, like every.
Pluto. Come on, Pluto. It's not even a planet, but oh wait, is it? It keeps like, sometimes it's a planet, then it's downgraded, then it's re-upgraded, then it's downgraded. When I was a kid, it was a planet. When you were kids, it wasn't. I thought one of my nephews told me the other day it's a planet again. I can't keep track of Pluto.
What?
No.
Why?
It is the cutest little thing.
That might set off the entire.
Right. Christ.
I'm not a proponent of destroying things in general.
Wait, set off like the entire like
So many died.
coalition.
So
I thought I heard it somewhere.
when we look at, so we say that this event happened, right? We say that's, what we know or what we think about the universe. Now we have to fast forward. We were at like between 13 and 14 billion years ago, right? Now we're going to fast forward 10 billion years to 4.6 billion years ago. And by the way, when I write BYA and MYA, that's standard abbreviation for billion years ago and millions of years ago. That's what we call a geologic time scale. It's a very big time scale, so instead of like listing all our zeros, we just say 4.6 billion years ago. 4.6 billion years ago, enough matter had collected from that explosion, from that bang. All this shrapnel, for lack of a better term, is hurtling outwards. And some of it is, in fact, running into each other, because it was all still fairly close. And it's running into each other, and it's kind of like a snowball. Like the farther on its journey it goes, it collects more and more stuff, right? Until it reaches a substantial enough size to represent what is essentially our planet. Part of the way that we've determined the age of the Earth is by dating rocks. So you guys should be familiar with radioactive dating. That's part of what we do. Remember when we talked about radioactive dating first semester, we said carbon we use for really young things. Things like potassium with a half-life of 1.3 billion years. We can use potassium to date stuff from like way back when. That's how we've managed to come up with that 4.6 number. What I love about that 4.6 billion number is the fact that no matter how long my career is, I'm never going to have to change the number I've memorized because like, what's the difference between like 1 year and 50 years when it's like 4.6 billion years as the total, right? So we can always just like ballpark it at 4.6 billion. Even in your lifetime. Even in the next 100 years, you guys are going to outlive my grandma. She's 99 now. Oh, grandma. She's charming. Picture a little old Polish woman. About yay high. She was 4'9" in her like heyday, like at her peak height. She was 4'9". And then she went in 1952 at 4'9", had a 15-pound baby.
Oh,
It's my dad. And my dad is 6'3". There's something funny about that, right? Like grandma,
Wait,
dad.
hang on. Is a 15-pound?
Normal babies are about 8 pounds. Yeah, ow, right? She almost died in labor, as did my dad, because not only was he 15 pounds and my grandma was so tiny, so, getting him out was a struggle. He decided to come out feet first, because, why not just be a bigger pain than you absolutely have to be, with his umbilical cord wrapped around his neck, because he'd been, like mashed in there. Because, think about it. Grandma was tiny and Dad was not tiny.
What if she
So.
was like 5'9"?
Oh, 4'9".
Oh.
Yeah. Riddle me that, right?
Wow. Okay, that's the difference.
It's a miracle either of them made it. Like literally, it's a miracle. That's what the doctor said when he was born. My dad was baptized in the delivery room because they didn't think he was gonna make it. Fun fact today. What? I know, I think that all the time. Like if my dad hadn't have made it, I wouldn't have made it. That's awesome. Like thank goodness he made it. And what's even worse is after he made it, the doctors were all like, well, yeah, you're lucky that your baby lived, but he's gonna have severe mental impairments. He's not gonna, don't expect much from this baby. He was the second person in my family to graduate college and went to U of M. Got a bachelor's in business and is a CPA. So, good job, doctors in 1952.
This wasn't brought up by me, but I do have a question.
Uh-huh.
Can you eat another child in the womb with twins?
It's like morphs. I asked my mom about it. 'Cause
It is, there are what we call disappearing twins. It is true that sometimes someone can become pregnant with twins and they'll never know. They will successfully only have one baby. Or there's an instance of babies who are born pregnant, and it's not because they were pregnant, it's because the mother was pregnant with multiples, but instead of embedding in the uterine lining like the baby's supposed to, it embeds in the other embryo.
So would that baby or baby grow 2 months old?
Well, they come out like with the baby still inside them is like a small fossilized tumor.
They remove that?
Yeah, they remove it.
Is it
I had
painful?
seen, and they're like, if they had to have surgery, I think like 2 weeks later just to remove it.
Yep. Isn't biology fascinating?
Yes, this is really the solid one. We should have more conversations like this.
I prefer that we made it.
We had more conversations like this when I taught health.
Oh yeah, Andre was one of them.
Can you imagine if you're like giving birth to a child and they're just like, oh, by the way, your baby's pregnant. Wait, what?
I think it's one of those things they just don't say out loud right away. It's like one of those things that they're like, let's go assess and figure out how to handle this.
Wait, so 8 pounds is like the normal?
So,
At least 6 people.
you guys, even if you outlive grandma, even if you make it past 100, you can still say 4.6 billion years. Like, don't worry about that. If you memorize that number, you're going to be safe. That will be the correct answer, even on Jeopardy. Just take it. It's at that point that we have dated things, we understand, based on the radioactive dating, that you guys understand how old Earth is. Then the question begs, what was your question that I said this whole chapter is about? Where did the animals come from? There are quite a few hypotheses for where those animals came from, and instead of, because I firmly believe that you guys have become so accustomed to being spoon-fed things, like I take all the learning from my brain and somehow put it in your brain, that you don't go back to the original source to figure out where these hypotheses are from. Now, I tried to find the original source for 3 of the hypotheses that will cover this chapter. And would you believe they were published in 1970 and 1977? And they still want to charge me for those articles? The authors are dead.
Does that make it worth like a lot more money?
No, it's common knowledge now. It's in every textbook about biology that's been published since like 1980. And they somehow still want to charge $15 per view of that article. So I had to find you the free version. Sorry. So if you go to Plus Portals, here we go. What to do on Plus Portals, you're going to look for the Origin of Earth article, or Origin of Life.
I have a question about.
There's 3 articles there. You're looking for the one about the origin of life.